It is generally not advisable to use aluminum wire with wire caps due to several reasons. Firstly, oxidation is a significant concern. Aluminum wire oxidizes when exposed to air, creating a non-conductive layer on the surface. This oxidation layer increases resistance at the connection point, which can lead to loose connections and overheating. Overheating, in turn, poses a fire hazard and can damage the connected appliances or the wiring itself. Secondly, creep is another phenomenon associated with aluminum wire. Aluminum wire is prone to creep, a process where the metal gradually deforms under constant pressure or load. This deformation can cause connections to loosen over time, especially in environments with temperature fluctuations. Loose connections increase resistance, leading to heat generation and potential failure of the connection. Thirdly, galvanic corrosion can occur when aluminum wire is used with dissimilar metals, such as copper, which is commonly found in wire caps. This corrosion weakens the connection, further increasing resistance and the risk of failure. The National Electrical Code, or NEC, provides guidelines and requirements for electrical installations to ensure safety and proper functioning. According to the NEC, aluminum wire is permitted for use in certain limited applications, but specific requirements must be met to mitigate the risks associated with its use. 1. Aluminum wire must be marked with its size and type, indicating that it is suitable for electrical applications. 2. Aluminum wire connectors must be specifically rated for use with aluminum wire. These connectors are designed to provide a secure and reliable connection that minimizes oxidation, creep, and galvanic corrosion. 3. Aluminum wire joints must be made using mechanical connectors or special aluminum connectors that are listed and labeled for use with aluminum conductors. Mechanical connectors apply consistent pressure to the connection, reducing the risk of loosening due to creep. Special aluminum connectors often incorporate features such as antioxidant compounds to prevent oxidation. It is important to note that wire caps are generally not approved for use with aluminum wire according to the NEC. Wire caps are designed primarily for use with copper wire and do not provide the necessary protection against the unique challenges posed by aluminum wire. Consider a situation where number 8 aluminum wire is used with wire caps for a 50 amps hot tub circuit. This scenario presents several potential problems. The use of multiple pieces of number 8 aluminum wire connected with wire caps does not meet the NEC requirements for aluminum wire connections. The potential for loose connections and overheating due to oxidation and creep is a major concern in this installation. The use of aluminum wire with wire caps is not considered kosher for code purposes and is therefore not a safe or reliable practice. It is highly recommended to have a qualified electrician inspect and replace the aluminum wire run with properly sized copper wire and approved connectors. Copper wire is less prone to oxidation, creep, and galvanic corrosion, making it a more reliable choice for electrical connections. Approved connectors for copper wire, such as crimp connectors or screw-type connectors, provide a secure and long-lasting connection. Replacing the aluminum wire with copper wire and using approved connectors will ensure the safety and reliability of the electrical installation for the hot tub. When selecting copper wire, it is essential to choose the appropriate gauge or size to handle the 50 amps current requirement of the hot tub. The NEC provides tables and guidelines for determining the correct wire size based on the amperage and other factors, such as the ambient temperature and the type of insulation. Using an undersized wire can lead to overheating and potentially cause a fire. In addition to using properly sized copper wire and approved connectors, it is also crucial to ensure that the electrical installation for the hot tub includes all the necessary safety features, such as a ground fault circuit interrupter, or GFCI, protection. A GFCI is designed to detect ground faults, which can occur when electrical current leaks outside the intended circuit path. When a ground fault is detected, the GFCI quickly interrupts the power supply, preventing electrical shock and reducing the risk of fire. GFCI protection is typically required for electrical circuits serving outdoor hot tubs and spas. The electrical installation should also comply with all applicable local codes and regulations. Local codes may have additional requirements or restrictions beyond those specified in the NEC. It is essential to consult with a qualified electrician who is familiar with the local codes to ensure that the installation meets all the necessary requirements. The qualified electrician should also perform a thorough inspection of the existing electrical system to identify any other potential hazards or deficiencies. This inspection may include checking the condition of the wiring, the grounding system, and the overcurrent protection devices, such as circuit breakers or fuses. Any identified issues should be addressed promptly to ensure the overall safety and reliability of the electrical system. In summary, the use of aluminum wire with wire caps for a hot tub circuit is generally not recommended due to the risks associated with oxidation, creep, and galvanic corrosion. It is also not compliant with the NEC requirements for aluminum wire connections. It is highly recommended to replace the aluminum wire with properly sized copper wire and use approved connectors to ensure the safety and reliability of the electrical installation. Additionally, it is essential to ensure that the installation includes GFCI protection and complies with all applicable local codes and regulations. Consulting with a qualified electrician is crucial to ensure that the installation is performed correctly and meets all the necessary safety standards. When addressing electrical work involving aluminum wiring, particularly in safety-critical applications like hot tubs, it's essential to understand the specifics of materials, codes, and best practices. Let's delve deeper into the properties of aluminum, the appropriate connection methods, and the relevant sections of the National Electrical Code. Aluminum possesses several characteristics that differentiate it from copper, the more commonly used conductor in residential wiring. Firstly, its conductivity is lower than copper. This means that for the same amperage, an aluminum conductor needs to be larger in diameter than a copper conductor. Secondly, aluminum has a higher coefficient of thermal expansion than copper. This means that aluminum expands and contracts more with temperature changes. Thirdly, aluminum forms an oxide layer when exposed to air, which, while preventing further corrosion, is non-conductive. This oxide layer is a key reason why special connectors and practices are required. The NEC addresses the use of aluminum conductors in various sections. Section 110.14b covers electrical connections and emphasizes the importance of suitable connections. For aluminum conductors, this means using connectors that are specifically listed and labeled for use with aluminum. These connectors are designed to accommodate the expansion and contraction of aluminum and to break through the oxide layer to create a good electrical connection. Wire caps, also known as twist-on wire connectors, are generally not suitable for aluminum conductors, especially when connecting aluminum to copper. The dissimilar metals can cause galvanic corrosion, and the wire caps are not designed to maintain consistent pressure on the aluminum conductor as it expands and contracts. This can lead to loose connections, arcing, and overheating. Approved connectors for aluminum conductors include mechanical set screw connectors, compression connectors, and crimp connectors. These connectors are typically made of aluminum or are plated to be compatible with aluminum. They are also designed to provide a gas-tight connection, preventing oxygen from reaching the conductor and forming more oxide. When making connections with aluminum conductors, it's essential to use an antioxidant compound. This compound helps to break down the oxide layer and prevents it from reforming. The compound should be applied to the conductor before inserting it into the connector. The NEC also addresses the sizing of conductors in Article 310. When using aluminum conductors, it's important to consult the ampacity tables in 310.15 and to ensure that the conductor is sized appropriately for the load. Aluminum conductors typically need to be larger than copper conductors for the same load. For example, Table 310.16 provides ampacity ratings for conductors based on insulation type and temperature rating. It's essential to select a conductor with an ampacity that is sufficient for the 50 amps hot tub load. In the specific scenario of wiring a hot tub with aluminum conductors, there are additional considerations. Article 680 of the NEC covers swimming pools, fountains, and similar installations, including hot tubs. This article has specific requirements for wiring methods, grounding, and bonding. For example, 680.42 requires that all metal parts of the hot tub and its associated equipment be bonded together to form an equipotential bonding grid. This grid helps to minimize the risk of electric shock. Furthermore, 680.26c requires that the bonding conductor be solid copper insulated and not smaller than number 8. The equipment grounding conductor that runs with the circuit conductors to the hot tub must also be sized according to 250.122, which bases the size on the overcurrent protective device. The overcurrent protective device, such as a circuit breaker, must be sized according to 240.4, which protects the conductors from overcurrent. In the case of a 50 amps hot tub, a 50 amps circuit breaker would typically be used. In summary, using aluminum conductors for a hot tub circuit requires careful attention to detail and adherence to the NEC. Wire caps are not suitable for aluminum conductors. Approved connectors, antioxidant compound, and proper conductor sizing are essential. Article 680 of the NEC provides additional requirements for hot tub installations. It is highly recommended to consult with a qualified electrician to ensure that the installation is safe and compliant with all applicable codes. If aluminum wire has already been installed using improper methods like wire caps, it is crucial to rectify the situation promptly to prevent potential hazards. Firstly, disconnect the power to the circuit at the breaker. This ensures that the work can be performed safely without the risk of electric shock. Secondly, remove the wire caps and inspect the aluminum conductors for any signs of corrosion or damage. If the conductors are corroded or damaged, they may need to be cut back to expose fresh, clean aluminum. Thirdly, apply an antioxidant compound to the cleaned aluminum conductors. This compound will help to prevent further oxidation and ensure good electrical connection. Fourthly, install approved connectors that are specifically listed and labeled for use with aluminum conductors. These connectors should be tightened according to the manufacturer's instructions to ensure a secure connection. Fifthly, verify that the conductors are properly sized for the load. Consult the NEC ampacity tables to ensure that the conductors can safely carry the 50 amps current of the hot tub. If the conductors are undersized, they should be replaced with larger conductors. Sixthly, inspect the grounding and bonding system to ensure that it is properly installed and connected. All metal parts of the hot tub and its associated equipment should be bonded together to form an equipotential bonding grid. Lastly, test the circuit to ensure that it is working properly. Use a multimeter to verify that the voltage is correct and that there are no shorts or ground faults. If any problems are detected, troubleshoot and correct them before restoring power to the circuit. By following these steps, the aluminum wiring can be made safe and compliant with the NEC. However, it is important to remember that working with electricity can be dangerous, and it is always best to consult with a qualified electrician if you are not comfortable performing the work yourself. A qualified electrician will have the knowledge, skills, and experience to ensure that the installation is done safely and correctly. They will also be familiar with the local codes and regulations that apply to electrical work in the area. In addition to the safety aspects, using a qualified electrician can also provide peace of mind. Knowing that the electrical work has been done properly can help to alleviate any concerns about potential hazards or problems. The cost of hiring a qualified electrician is often a worthwhile investment in the long-term safety and reliability of the electrical system. If the decision is made to replace the aluminum wiring with copper wiring, the process involves similar steps but with some key differences. Firstly, disconnect the power to the circuit at the breaker. Secondly, remove the aluminum conductors and inspect the junction boxes for any signs of corrosion or damage. Thirdly, install new copper conductors of the appropriate size for the load. Consult the NEC ampacity tables to determine the correct wire size. Fourthly, connect the copper conductors to the circuit breaker and to the hot tub equipment using approved connectors. These connectors should be specifically designed for use with copper conductors. Fifthly, verify that the grounding and bonding system is properly installed and connected. Sixthly, test the circuit to ensure that it is working properly. Using copper wiring eliminates the concerns about oxidation, creep, and galvanic corrosion that are associated with aluminum wiring. Copper is also a better conductor of electricity than aluminum, so smaller gauge conductors can be used for the same load. However, copper wiring is typically more expensive than aluminum wiring. The choice between aluminum and copper wiring depends on a number of factors, including the cost, the load requirements, and the local codes. In some cases, aluminum wiring may be acceptable if it is installed properly and meets all the applicable requirements. In other cases, copper wiring may be the preferred choice due to its superior performance and reliability. Ultimately, the decision should be made in consultation with a qualified electrician who can assess the specific circumstances and provide expert advice. Remember that electrical work should only be performed by qualified individuals who have the necessary training and experience. Working with electricity can be dangerous, and it is important to take all the necessary precautions to ensure safety. If you are not comfortable performing the work yourself, it is always best to hire a qualified electrician.